Rate law and stoichiometry. In this video, we're going to be looking at the components of a rate law and learning how to write them. So right now, we'll just be learning how to write them in the least accurate way, actually, and we'll slowly build to the most accurate way. So we're going to look at a chemical equation, look at the stoichiometric coefficients, and write a rate law. And then in future videos, we'll learn how to make this more accurate based on either a reaction mechanism or based on experimental data. So first off, what is a rate law? So a rate law is when you look at the concentrations of a reactant and you compare what the rate of the reaction will be based on those concentrations. The general form for it is written here. So let's say I have two reactants, A and B. A very typical general rate law would be rate is equal to K, where K is some constant that's just dependent on the individual reaction. This isn't something that's a constant over all of the universe, just the individual reaction. And then multiplied by each reactant raised to an exponent. So that's the most general version. You wouldn't ever really want to write it like that. You would want to put in numbers. So then how do we figure out what those numbers are? What is X and Y? So if we're given no information about the reaction other than here's the equation, things happen. Well, we can try to write a rate law off that. And what we can do is we can use the stoichiometry of the equation to do so. What we'll learn next time is that if we know the mechanism, we can guess the rate law based on the stoichiometry of the mechanism and the rate limiting step and many things that we'll cover. That too has problems. So the absolute best way to do it is going to be to use experimental data and your impressive powers of deduction and some problem solving that I'll teach you how to do to figure out the actual 100% rate law. Now, in reality, we typically end up looking at these last two and comparing them to decide, well, based on experimental data, is our mechanism correct, or trying to derive a mechanism? Real science tends to do a lot of going back and forth there. In this video, we're going to stick to using stoichiometry if we need to, just to kind of get you comfortable with the idea of a rate law first, and then we'll move into the other ones. So this method lets us take a guess based on the coefficients. So we can take and say, well, reactant A has a coefficient. In this case, I kept it general, so I used a little a and raise it to that. Reactant B has a coefficient little b, and we can raise it to that. This isn't particularly accurate, and there's many, many reasons for this, and these reasons are important because if this was a one-step reaction with very simple molecules, it would seem like it should work, and yet it doesn't. So for one, many, many reactions are multi-step. We'll take care of this in the next video. Two, a lot of times they depend on orientation. So maybe they're complicated molecules, and if they interact like this, they won't react. But if they interact like this, they will. Or maybe it's really finicky and it has to interact in just one little tiny particular way. All of that is going to play a role on how fast the reaction happens and how much of each concentration you have to have. This also doesn't consider activation energy, which is a slightly different idea that we'll be covering much later. So as a quick review, the rate of reaction is often related to the reactants, sometimes all of them, sometimes one, sometimes just a few. The rate of the reaction can be written as, and I kept the generic formula where we just have A and B as reactants, but the rate times by some constant, which we call K, times by each of the reactants raised to a random coefficient. Now, what that coefficient is can be determined many different ways, the least accurate of which I showed you how to do here, which is to raise it to the power of the stoichiometric coefficient, or in other words, the coefficient in the balanced reaction. And we'll talk about more ways to do that next time.